Good afternoon. I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest video. This one is titled Model Chaos. During the winter season, there's really a lot of times in which the models just tend to go all over the place with potential future storms, for example. And I'm going to show you exactly what that looks like today. There's a lot of model chaos going on about a potential storm around the 14th of January. And get my laser pointer out here. This diagram here represents the process involved whenever you have any kind of chaos in any system. It creates some form of disorganization. Initially, you have your initial conditions of the model, and then out over time, you see how these blue arrows get further apart over forecast time before the final result, the forecast, actually occurs. This is a case of chaos. Edward Lorenz mentioned it. And, initially with any kind of state of the atmosphere, there's going to be some sort of entropy, some sort of disorder in any type of system like this. When we have a lot of perturbations in the atmosphere, timing and placement of specific synoptic features are going to make a huge difference in the end result of any forecast. So I figured this was an appropriate example here to start things off today when I titled the video Model Chaos. How things are more certain and highly confident with ensemble systems in the shorter term, but as you get further out into the future in the forecast time, the varying possibilities increase, a wider range, lower confidence on this side of the diagram. So let's go right into it. First thing I'm going to do today in the video is I'm going to talk about the various model runs. We're going to take a look back for the GEFS model, the GFS Ensemble Forecasting System. We're looking at the past 3 days of the 12Z model data. We're looking at the upper air forecasts for the 14th of January in all three of these cases. All right, and whenever we're looking at these upper air charts, the 500 millibar level or 18,000 feet above our head, I've explained this before that the blue coloring and the green coloring indicate lower than normal heights associated with troughs. Troughs in the upper atmosphere are typically associated with unsettled weather and cooler temperatures. Whereas where you see the brighter oranges, that is indicative of higher heights, in many cases upper level ridges, and those upper level ridges are associated with drier weather and milder conditions. So if we look, I'm going to start over here on the far left on 3 January. This was the forecast. This was a 12Z 3 January model run for the 14th of January, showing the blue coloring off the southeast coast. I want you to focus on this area here as I go through the progression of these comparisons of the models. So you'll notice that we have lower heights situated across Florida and just off the southeastern coast of the U.S. There are higher heights upstream, generally located from the northern plains up into central Canada. And then we do see some lower heights again there off the U.S. west coast. Now, 24 hours later here on the 12Z04 January run for the 14th of January, notice I still have that same blue coloring here off the southeast coast, and that is associated again with lower than normal heights. And I still see some ridging, a little bit of upper level ridging and higher heights over central Canada. Those heights aren't nearly as strong as they were back on the forecast at 12Z on the 3rd of January, but we still see those orange colors here in central Canada showing upper level ridging, higher heights. And then we have that troughing again off the U.S. West Coast or northwestern Pacific coast as well as off the west coast of Canada. Let's move ahead now and take a look here on the right. Now this is today's latest model run at 12Z, the 5th of January 2023. And look, this placement of this blue feature here, the blue coloring, the troughing and the lower than normal heights still remains off the southeastern U.S. coast. And now we see on the GEFS model, it's trying to strengthen these higher heights, basically increase them, make it stronger up here, more anomalous and higher height values over the central Canadian area as well as Hudson Bay. And then we still see that troughing, this green coloring indicating the upper level troughing off the U.S. west coast on today's midday model run. So the storm signal out of all the last 3 midday model runs, the 3rd, the 4th, and the 5th of January, still show this storm signal, lower heights, a little bit of a negatively tilted trough off the southeastern U.S. southeastern coast Now let's take a look at the operational model runs. Same story here. We are looking at the midday model run from the 3rd of January on the far left. We're looking at the midday model run here in the middle of yesterday, 4 January. And now this is today's, the 5th of January, midday model runs, 12Z model run. Look how more widely varying the GFS operational model is with the placement of this storm off the southeast coast. The past 3 days. The past 3-day midday model runs. Look at the difference here. So on the 3rd of January, the storm was way out to sea here, not even close to the east coast. We had a little bit of troughing and lower thickness values coming down the mid-Atlantic, but the storm wasn't even close to the U.S. East Coast, the southeast of mid-Atlantic, not even close. Now, yesterday's midday model runs, look what happened. Now it's starting to show, the GFS operational starting to show something closer, some sort of storm system closer to the mid-Atlantic coast. In fact, yesterday's midday model run showed a mix of rain and snow into Virginia along the coast all the way down to North Carolina, with a sprawling 1035 millibar very cold Arctic high situated over southwestern Minnesota. On the front side of the Arctic high, we get northerly winds and colder air funneling in to the mid-Atlantic and the eastern U.S. in general. Now look at today's model run. Where's the placement of that storm? It's now inland over western Virginia on the 14th of January. See the differences? See how far all over the place the GFS operational model run has been the past 3 days? All right, so there's lots of variability in this particular operational model, the GFS. Now, let's take a look at the 12Z European operational model runs, and let's compare it similar here. So I actually did reverse order here with the European operational. I apologize for that. So now on the far left, I have today's model run, the 5th of January midday run. The middle shows yesterday's model run. No, that shows 0Z. So this was the overnight model run into this morning, the 5th of January. And then here is the 12Z model run from the 4th of January. So we're looking at the midday model run today on the left, 5th of January model run. We're looking at the overnight midnight model run for the 5th of January in the middle. And then this is yesterday's midday model run, the 4th of January. Look at the consistency of storm placement here between all three of these graphics, okay? Very similar setup. We have much colder look on this particular model run, the European operational. And you'll see a lot more precipitation. It's heavier. It's closer to the coast. This is today's. And you'll notice these heights upstream, these thickness values are forming a ridge configuration over the western U.S. up to south central Canada. So we got heights rising here, and the higher these heights rise here upstream, the deeper the trough becomes in the eastern U.S. So, in fact, if we look at all three of these graphics, you'll notice on today's 12Z model run, the heights are highest, or the ridge is strongest on today's run. See how tall these red dashed lines get into south central Canada as compared to yesterday's run, where those milder red dashed lines, those higher thickness values, aren't quite going as far north into south central Canada. And then this was yesterday's model run, about 24 hours ago, not showing nearly as strong of a ridge here, okay? And that makes a difference in the availability of colder air into the storm system because, again, the higher these heights build, the stronger the ridge, the deeper this trough is going to be downstream of that ridge, and the greater the availability of colder air coming down from eastern Canada into the storm system, okay? The flatter this ridge is, the less likely we're going to have a cold enough air to have a snowstorm or any type of wintry precip across the mid-Atlantic. So in general, though, look at the placement. So today, midday run, we got the placement of the storm system intensifying right off of the North Carolina coast. This was overnight into this morning, showing the placement of that low a little bit further offshore. And then this was yesterday at midday. Look at the similarity of this one here on the far right. This is yesterday, 12Z, 4 January model run. Look where the Euro placed it, the low at 998 millibars off the North Carolina coast. Look at where today's is. It's almost identical to where it was 24 hours ago, the placement of this very intense storm system. So I like the looks of the European model right now. I really do, because it's been way more consistent than the GFS operational. I'm going to get to some other stuff here in a moment. When we talk about the the GFS Ensemble 500 millibar level forecasts, one other thing I wanted to mention that I forgot to mention before I move on is it just seems to me like the placement of this trough, these lower heights, it really hasn't changed much, right? You kind of see where it is in all three of these frames going back to the 3rd of January 12Z model run. But why is the placement on the operational run so far off, so different, even though this is fairly consistent, this signal at 500 millibars? That is a sign of a model that is not sure of itself. I really don't trust this 12Z GFS model run at this point in time. It's not matching up with its ensemble member, with ensemble run. And, you know, let's just look at the European operational here. Now, I'm making this video. The European ensemble 500 millibar is updating right now. So I'm going to go back to that at the end of the video. We're going to look at what it looks like on the past 3 days and compare. We're going to do it real time at the end of the video. So I'm going to move on now, and I'm going to talk about the temperature anomalies in degrees Fahrenheit. Because we have this ridge right here building up higher or becoming more amplified upstream of this trough, guess what's going to happen to the temperatures? The greens and the blues indicate below normal temperatures. And it's not really a shock here. We got stronger ridging upstream here, so we have warmer temperatures beneath the ridge, and we have much colder temperatures basically coming down from eastern Canada into the base of this trough, right? So portions of like eastern North Carolina and eastern Virginia, according to the latest European run. Now this would be for Thursday. This is Thursday the 12th of January. So this is a couple days before the potential storm on the 14th. But it's kind of just sitting there and setting the stage. So this is the temperature anomaly forecast, degrees Fahrenheit, on the European control or operational model, showing 10 to 12 degrees Fahrenheit below normal temperatures across northeastern North Carolina into Virginia, parts of West Virginia, western PA. And look it up here in New England, it's definitely colder on this particular model. Now, over here on the right, I'm showing the same thing, temperature anomalies, degrees Fahrenheit, generally showing that area of colder than normal temps from northern Georgia, South Carolina, right to North Carolina into Virginia. See this across the mid-Atlantic? That's due to that colder air coming into the system, into the trough. Now let's take a look at the Canadian model and let's compare. Over here on the far left, I have the 5th of January. In the middle, I have the 4th of January. And on the far right, I have the 3rd of January, the different model runs. This is a model run from today on the far left. Notice the blue coloring here indicating below normal heights. It's there. Look over here in the middle. This is the forecast from yesterday's midday model run, still showing that signal, that storm signal with lower heights off the southeastern coast. And then finally, this is the 3rd of January. So really, the Canadian ensemble is showing a very similar setup, storm signal as the GFS ensemble. So see the blue coloring here, it's generally in the same position. And you'll notice here this was the 3rd of January, it showed the ridge a little bit stronger back on the 3rd as compared to today where that ridge is more flat. Okay, so we have a flatter look on today's midday Canadian ensemble. So that's a big difference though, right? Again, because the more this ridge builds, the higher these heights become, the deeper the trough becomes downstream of that ridge axis. And so we're going to have to keep an eye on it. We see the storm signal, but will there be cold enough air for wintry precip associated with this storm? Let's look at the Canadian operational model runs. Now, I'm only able to go back 2 days on this. On the far left here, I have the 12Z 4 January model run showing a very intense area of low pressure. This storm system is well offshore, though. We do see a little bit of snow into portions of the Carolinas inland, in the inland portions of the Carolinas. We have a nice strong anticyclone to the northwest, 1034 millibars, clockwise flow around that, and bring in some pretty cold air. Now, this was yesterday's model run, okay? Now, let's look at today's model run here on the right, and it's way different. So see the inconsistencies now with the Canadian operational model run? Notice here, yesterday on the midday run, it's way offshore, the storm. It's much more intense. Now today on the 12Z model run for the same time period, 12Z for the 14th of January forecast, look what we have going on here. So instead of it being on the cold side of the storm across the mid-Atlantic, we now have a warm tongue, basically, an area of warmer air streaming northward right along the whole east coast, all the way up to New York State. So nothing but rain on today's midday model run from the Canadian operational. Yesterday, it was a pretty close call as far as the track of the storm. It was very intense offshore. Today, inland. So see that? Not a lot of confidence in the Canadian model either. Now let's take a look at the Stratospheric Polar Vortex forecast. I think this is going to play a big role in whether we can get some sort of colder air in the troposphere where we live. We can get some colder air to come down into the eastern U.S. for this potential storm on the 14th. All right, so I'm showing you 10 millibar level temperature and anomalies here. Purple indicating the greatest or coldest temperatures anomalies. The brown coloring indicating the warmest temperature anomalies. All right, so notice here the stretched out appearance, the elongation of the polar vortex. This forecast on the far left is for 9 January, next Monday. See how elongated this is? Now move to the middle here, middle graphic, and look at what we got. We have that stretched out look of that stratospheric polar vortex again. Look at the purple coloring here. That's very cold temperatures in the stratosphere. If that were to translate down towards the surface, and these green colors are also colder temperatures, if this could translate down to the surface, this may be enough, this elongation of the polar vortex in the stratosphere may be enough to allow for colder temperatures, cold enough temperatures for a potential storm system around the 14th. Here's the 14th on the far right. Look at the purple coloring here, all the way down to Pennsylvania into New England, parts of Northern Virginia. So GFS is showing that elongation of the stratospheric polar vortex again. This could have huge implications on whether we have enough cold air for that storm system on the 14th. Now, this is the 17th. This is after that potential storm system. And look, GFS is being way more persistent in elongation of that polar vortex in the stratosphere. And look how deeply purple these colors are. Some of our past cold waves back in late November, back in late December, had a very similar look. I'm not saying the tropospheric temperatures where we live, the Earth, where on the ground here, are going to be that bitterly cold. It doesn't appear that way. But this really is an intriguing situation here to me. This is 17 January, and then this over here on the right is 18 January, showing elongation of the stratospheric polar vortex and potential colder temperatures for the eastern U.S. And this has been very, very, very persistent. Now, we look at the GFS ensemble forecasting system, stratospheric polar vortex forecast, very similar forecast for the 9th of January. You can see this. This is the 9th of January on the GFS. See that? And this is the 9th of January on the GEFS ensemble. Very similar. The elongation is occurring of the stratospheric polar vortex. Look over here on the right. This is for Friday, the 13th of January. You didn't know there was a Friday the 13th, did you? I just realized that last night. Anyway, look at the purple coloring going down again towards Pennsylvania, New York State, New England, up over eastern Canada, all the way up towards the North Pole area. See this? But the elongation's there into the east. The 13th of January. Now this is the 14th of January. Now there's a difference here on the 14th. The GEFS has the majority of the coldest stratospheric air moving offshore. The GFS has it more north-south. See that? This is the 14th on the GFS. The orientation of that elongated vortex in the stratosphere is more north-south. The GEFS has it more north-northwest, south-southeast. Okay, so that's a big difference. Here's additional graphics for the forecast from today's midday run for the stratospheric polar vortex on the GEFS model, showing this thing pivoting out over the North Atlantic, the elongation, and then definitely here by the 18th of January, it's well offshore, well east of North America. Big difference here in the extended outlook from GEFS versus GFS. Remember with GFS, 17th of January, a much colder look in the eastern U.S. 18 January, cold look in the eastern U.S. But the GEFS is further offshore. See that? So that's going to be interesting to watch to see which of these models is right as far as the orientation of this axis. Does it set up more northwest to southeast over time, like the GEFS is showing, or is it still going to be lingering more north-northeast to south-southwest across the eastern U.S.? That's going to make a big difference potentially in our temperatures. Okay. Let's take a look at the European model from today's midday run, 5 January. Very similar again for 9 January. There's no debate. We have high confidence in how the vortex in the stratosphere is going to basically elongate. The orientation looks very similar, northeast to southwest. See that? Northeast to southwest on the GEFS, northeast to southwest on the GFS. So all three of these model runs are in very good agreement for the orientation of the stratospheric polar vortex on 9 January. Now let's look in the middle here. Forecast for 13 January. Notice the coldest temperatures in the stratosphere remain north of the United States. And then by the time we get over here on the far right, 14 January, Saturday. Now this is the key day for that storm that I showed. All right, so will this impact the mid-Atlantic? Will we have cold enough air to come down? Could there be that connection between the very cold air of the stratosphere, that elongation stretching down into the eastern portions of the U.S.? That is the golden question right now. So that's the latest on the stratospheric polar vortex forecast. I think that could have a huge role in whether it'll even be cold enough air coming up for that 14 January potential storm. Now the MJO forecast, latest update on this today, showing GEFS V12 here on the left, showing a rotation into, by the 11th of January in phase 8, 13 January phase 8, and then working its way down into phase 1 between basically the 14th and the 19th of January. If you look at the CFS V2 extended outlook here in the middle, showing a very similar track. It looks to me like it's a little bit, yeah, it's about the same time period, 13 to 17 January on the CFS for MJO phase 8, and then 17 to like 21 January it looks like for phase 1, and then the CFS extended shows it going into phase 2, and even potentially into phase 3 where we have convection in the Indian Ocean. Looking at the European forecast here on the far right, showing again very similar, a little bit different configuration. Phase 8, 11 to 15 to 16 January, then phase 1 through 19 January. And then the other major difference here is at the end on the European, showing it getting closer to the null phase by the 19th of January. Now, I wanted to show, I shared these on social media yesterday. I wanted to briefly cover the different MJO phases and what the upper air pattern might look like. Now, on the first few slides, I'm going to show you La Nina conditions in all three. And I'm going to compare La Nina plus MJO phase 8 in January, what the upper air pattern looks like. La Nina plus MJO phase 1 in January, and La Nina plus MJO phase 2 in January. So La Nina plus MJO phase 8 in January, look at the purple and the blue coloring indicating troughing and lower than normal heights across the eastern U.S. and higher than normal heights off the U.S. West Coast. Now, we know this is not occurring right now, right? We know we don't have this huge upper level ridge, higher height center off the west coast of the United States, off the Pacific Northwest, off Seattle. We just don't have that right now. But with MJO phase 8, will that really result, will that be a contributor here to that troughing around the time that storm develops down here off the southeast coast? It's going to be interesting to watch. But this is typically what you see with a La Nina winter plus MJO phase 8 in January. You look at La Nina plus MJO phase 1 in January, which we're forecast to go into 8 and to 1. The troughing is not nearly as deep. You do have troughing over the East Coast, Mid-Atlantic, New England, but it's much different, right? See the orientation of the trough here? And it's much deeper with the deeper blue colors with phase 8 in January. With phase 1 plus La Nina, it's not as deep. There's lighter blue coloring here. And additionally, with MJO phase 1, you would typically have, in a La Nina, you'd have an upper level ridge or high height center over the Gulf of Alaska. And we know that's not happening right now. And it's not forecast to happen either, by the way. La Nina plus MJO phase 2 in January, showing the green coloring along the East Coast, indicating milder conditions, most likely in this case with higher than normal heights, upper level heights. We still have that big ridge over the Northeast Pacific. Now, let's take a look at the past January phase 8 and the temperature departures. All right, so I went back and looked at past Januaries when we had phase 8 in the MJO and what the temperature departures look like in those Januaries. So the first one we're going to start off with is January 2009. The red line in each of these slides I'm going to show you represents how the MJO moved in the month of January. Red line indicates January. And then these little numbers next to it indicate the day of the month. So here's 17 January back in 2009, here's 18 January, and so on. So in January 2009, the MJO rotated basically from phase 7 through mid-month, and then it made it into phase 8 and phase 1 from 16 to 24 January. So for about an 8-day period, the MJO was in phase 8 and phase 1. And look at the graphic here on the right showing temperature anomalies, mean or average temperature anomalies for the entire month of January 2009, where we have the coldest temperatures up in the upper Midwest over to New England. We do have the lighter blue colors here, not nearly as cold, but still below normal. If we look at January 2011, this is when the MJO went into phase 8. It went into phase 8 from 23 to 28 January over a 5-day period before moving back into the null phase, a small inner circle here. And we look at the temperatures, okay? Look at the temperatures. The greens indicating temperatures on the order of 5 to 7 degrees Fahrenheit below normal. So it was quite cold east of the Rocky Mountains in January of 2011 when we had the MJO in phase 8 for just 5 days. Now, let's take a look at January 2016. We had MJO in phase 8, then rotating into phase 1, eventually over to phase 2 even. But it was in phases 8 and phase 1 from 7 to 13 January back in 2011, or 2016 rather. Look at the temperature anomalies. We had colder than normal temperatures concentrated across the mid-Atlantic, down to the Gulf Coast, all the way over to Texas, even some cooler than normal readings out in the western U.S. And then finally, we look back at January 2019, and this was a little bit crazier. Remember, the red line represents January, what the MJO was doing in 2019. So we started over here in January in phase 6, where convection was concentrated in the Western Pacific, and that moved in by the 5th of January. We were heading out of phase 7. So 6 and 7, the first 5 days of January, and then moved into phase 8 before rotating right into the null phase temporarily and then back over to the maritime continent side, phases 4 and 5. Look at the temperature anomalies here. So we had much wider variability in the MJO this particular year. It was in phase 8 for 7 days from 5 to 12 January, and it was actually milder than normal in the southeast up to the mid-Atlantic, slightly above normal for that January 2019. Before I move on, I forgot to mention, this particular plot of the MJO looks very similar to the forecast right now. Now, I will say in 2016, the MJO, see how far this red line is, this line is from the small inner circle? That means the magnitude is fairly significant. This year, the MJO is in phase 8 and phase 1, but it's a little bit closer and does not have as great magnitude this year as compared to 2016. But I like the way it's rotating. So I was looking at the trace of the MJO from 8 to 1 and possibly into 2. It looks very similar to the current forecast now. Again, maybe not the same magnitude, but the general track of it. All right. And by the way, that's only looking at the MJO, okay? I didn't delve into, okay, was it a La Nina year these years? Was it a, what were the other teleconnections looking like? What was the EPO looking like that year, positive or negative? What about NAO? What about AO? What about the Polar Vortex and the Stratosphere that year, in these Januaries? I didn't look that deep into it. I was just solely comparing MJOs versus temperature departures. But yeah, I'm definitely interested. I might do a little more digging into those other teleconnections and what they were doing at the same time, and whether there was an El Nino or La Nina these respective Januaries too. And what was the state of the polar vortex? Were we looking at a splitting vortex, a displaced vortex, a strong polar vortex? There's a lot of variables here. But I just wanted to show you MJO versus temperature departures from previous Januaries where we've been in MJO phase 8. Right, now let's take a look at Teleconnections Forecast. I'm looking again at the European Ensemble, EPS, AO forecast up here in the upper left, green line indicating the average of all the 50 perturbed members of this ensemble system, showing a negative phase to the AO, working its way closer to neutral by the 12th of January, then slightly negative. This isn't really screaming anything because it's just slightly negative. It's not anything significantly above or below the neutral line here. The European EPS NAO 50 perturbed member forecast here on the right, showing negative right now, eventually working its way closer to neutral throughout all the way out through the 20th of January for the NAO. Looking at the EPO, Eastern Pacific Oscillation here in the bottom left, the Pacific could definitely be playing into our future again, okay? The EPO is now forecast to get a little bit stronger on the positive side. Generally, 15th, the middle of the month of January, right to the 20th. See the green line here? I've been watching this over the past few days. It's getting stronger on the positive side of the EPO, which is not really good news if you want winter weather in the eastern U.S. Okay, you want a negative EPO, where you get the upper level ridging to build into the Gulf of Alaska and along the U.S. West Coast. Looking at the graphic here on the bottom right, now this one's not good news either. It stays positive, the PNA. That's what we're looking at here, Pacific North American pattern. Whenever you have a positive PNA, that usually results in some sort of ridging in the western U.S. and troughing in the east. Well, it goes to negative after the 17th of January. Not really sharply negative, which that's good news if you want winter weather in the east, but it still goes negative, which means we would have some sort of troughing. These two, the EPO and then the PNA, these two in conjunction with each other plus La Nina could result in more in the way of troughing along the U.S. western portion. Here are my final thoughts of today's video. Look, there's lots of model uncertainty in operational model runs right now. There is just so much. And we kind of went over that. I showed you the wild swings in the Canadian operational and the GFS operational. Now, the one model that really sticks out to me as being most consistent with placement it's really the European operational model run. The ensembles continue to show a storm signal, no matter what we look at. We can look at the Canadian ensemble, we can look at the European ensemble, and we can look at the GFS ensemble. They're still showing that storm signal off the southeast coast around the 14th of January. European operational model is definitely colder. I showed you those temperature anomalies as compared. I didn't show you the GFS operational model temperature anomalies, but it's nothing. The Canadian operational is very similar to the GFS. It is way too mild for any kind of wintry precip on today's midday runs for GFS or Canadian. But that European model is continuing to dig that trough deeper, have the upstream ridge stronger, and that's therefore why it's colder. Now, will there be enough cold air in place for wintry precip if we see this storm? Too early to tell. Will the potential storm move inland? Does not make much sense to me with higher heights to the north. If we look back at the upper level, let's just look at the ensembles again here. Let's get by here. Okay. Here's a Canadian ensemble. See the colors here, the brighter colors here, the oranges and stuff up here? That indicates higher heights up here, or Canada in the vicinity of Hudson Bay. Over here on the far right, this is the forecast a couple days ago, showed higher heights. So see if the higher heights are over Canada? Let's go back. Let's go back and look at the GEFS, the GFS ensemble forecasting system. In all three cases from the past three 12Z model runs, 3rd, 4th, and 5th, look where the higher heights are. So, unless it cuts up right here, just inland of the East Coast, maybe it finds a weakness there in the ridge right here. But right now, it doesn't make a lot of sense to me to be too far inland like this, for example. So we just have to keep watching that. All right. Will this potential storm remain offshore with no impacts? That's a possibility. This thing could develop offshore and just continue to move east, northeast, away from the East Coast with very minimal impacts. Way too early to tell. Now, the stratospheric polar vortex elongation into the eastern U.S., to me, that's very critical in potentially allowing colder air to come south from eastern Canada. But how does that polar vortex elongation orientate itself? Will it orientate itself like the GFS is showing? More north-south like this? See this on the 14th of January? But look at the GEFS, a little bit further east than the GFS. Look at the European. Very similar to the GFS actually, but not quite as far south with it, with the elongation. So to me, this is going to be very important to watch over the next few days. Okay, what's the orientation of the stratospheric polar vortex going to look like, that elongation portion? Now the MJO is rotating towards colder phases, 8 and 1, and that typically yields colder air in the eastern U.S. in most cases. But are the Pacific influences going to overpower the colder MJO phases? All right. The MJO magnitude for the 8 and 1 is not very strong. Take a look at it. Let's keep going here. Here we go. All right. It gets stronger into phase 1 and further from this inner circle here, so it does gain a little more magnitude into phase 1. And you know, it's definitely gotten stronger or greater in magnitude 8 and 1 on the CFS V2 the past couple days. Europeans a little bit closer, less and weaker MJO influence as compared to the other two here. But really, what's the magnitude of that going to be? Will it be enough to overpower the Pacific influences? All right. In addition, the MJO, the colder MJO phases 8 and 1 are fairly short-lived. And meanwhile, the models are not picking up on the polar vortex elongation, I don't think, or the MJO colder phases with their projection of future temperature departures. The longer range models, you look at them and you just go, there's no chance we're going to get any kind of wintry precip. It just looks way too mild. So maybe the models right now, this is my theory, that maybe the models are not picking up on that polar vortex elongation or extension to the eastern U.S. or the MJO being in colder phases. And then finally, let's take a look at this last slide here. It definitely looks like it's going to be an active looking pattern. We're going to see multiple upper air disturbances moving from west to east, from California, west coast to the mid-Atlantic and the southeast coast. Again, this reminds me a lot more of an El Nino pattern, specifically for California. California usually is more nervous about landslides and flooding, mudslides during El Nino winters, not La Nina winters. So that one's real interesting this year. Some of these disturbances, by the way, are going to yield precipitation for the mid-Atlantic, but these temperatures are just going to be too mild for any wintry precip. It'll be in the form of rain. Now, right now, I'm looking at potential storm systems moving through the 9th and the 11th of January with mild temps. This is just going to be a rain in the mid-Atlantic. 9 and 11 January looking rain. Okay. The big storm potential, again, remains around the 14th of January per the latest ensembles today, the 12Z run on 5 January. Now, will the storm take an inland track with a surge of southerly winds and rain up the east coast, or will the storm take a more offshore route associated with a deeply digging trough and colder air moving southward on its backside? The source region in that case, the air mass source region, would need to be eastern Canada, as mild air is generally upstream associated with that ridge over central Canada. We just don't have a lot of cold air upstream, and that's really the problem. But as that polar vortex extends southward a little bit, the elongation of it, that could help set up a more of troughing in the troposphere as far as the jet stream goes, and allow colder air to filter straight north to south from eastern Canada into the east. One thing I did look at is that troughing does come back to the U.S. West Coast after 17 January with another round of mild weather for a large chunk of the U.S. And that ridge shows back up in the eastern U.S. yet again after the 17th of January. So, you know, I'm not seeing any significant pattern changes at the present time. Let's see what happens, you know, with the stratosphere, polar vortex, as well as these MJO phases, you know, La Nina weakening. Let's see what happens as we get into late January and February, as far as perhaps a little bit more consistent cold, or maybe not at all. You know, maybe it's just going to be a mild winter all the way to the end. It's very possible. Now, I did promise you before I ended today's video, we'd take a look at those new European ensembles, the 500 millibar heights and anomalies. So let's shift gears here. Let me go back to where I was. Okay, here we are. Let me just refresh this and let's take a look here. Okay, so we're looking at 12Z. Let's go to the 14th. Okay, so you see that we have a little bit of troughing here on this is the troughing associated with that potential storm on the, this is morning of the 14th, Saturday. You're already starting to see more of a negative tilt of this thing. You see the upstream ridge here. And this is why I really don't believe this thing's going to go inland, because look at all this ridging here, these higher heights over Hudson Bay. Because usually, you know, sometimes storms can take those inland routes where they go up through the Midwest. right up into Canada this way, like this way, southwest and northeast, because there's troughing up here, so there's lower heights, but not in this case. So let's keep going. Now, again, very strong storm signal. See that? See the green covering here off the coast of South Carolina and Georgia? We have a negative trough, tilted trough, and then it just kind of moves off. And then, there's your pattern again. Look where your troughing sets up again, 17 January, off the U.S. West Coast, Pacific Northwest specifically. And then let's see, not really much change. The troughing is over here. The lower heights are in the western U.S., and the higher heights are in the east through the 20th of January. So we need some things to change here. We don't see any high latitude blocking either here in the North Pacific with an upper level ridge. We do have higher heights here across northeastern Canada, but we really don't see a strong ridge building here, potentially resulting in a negative NAO. So just my thought. So let's go back, before I end this presentation, let's go back to the 14th. All right, so let's go to 12Z on the 14th of January. This looks very favorable for a storm to develop right in this location, and that's what the European operational is showing. By the way, the European operational matches up fairly well with its ensemble here. Okay, now let's do this. Let's go back now 24 hours previous, and let's look at that same time period. See, it's still there. See how consistent this is? Right here off the southeastern coast. That was yesterday's midday model run. And then this was the day before. Let's see what it showed. Let's go to the 14th, 12Z, right there. See that? So it's persistent. The signal's there the last 72 hours, really, that signal's been there. So again, it'll be interesting to see what happens overall, but I just wanted to end today's video by showing you that. That's the latest and greatest from the European ensemble at 500 millibar, showing the overall upper air pattern. All right, that wraps things up today on the video. I hope you enjoyed it, and we'll keep updating you. We'll see what happens here. I'm not giving up hope. Perhaps we'll see a winter event here in the Mid-Atlantic around the 14th of January. All right, until next time, everybody, take care and God bless everyone.